Hello. Good morning. Good evening. Let's see where I left off yesterday. Was he running the release build? Oh yeah. Oh yeah, I had been trying to increase the frame rate of this thing. I was thinking that this average render time is too high. It shouldn't be that high. Over here on the egui page, it claims that it's less than a millisecond per frame, so I don't know. Yes, you are first. Develop it. Welcome. Yeah, mean CPU time says 1 millisecond. This is a lot higher. Out of curiosity, drop it back to 60. That app? Or was it in main? Main. 60? This seemed to take longer when I moved the mouse with the frame rate being higher. I want to try to solve that, fix that. So the way to fix that is to not redraw immediately on a redraw. If we haven't reached the time, the next frame time yet. So that would be here somewhere, right? We have next draw time. I suppose I take these two lines. It would be a window event, right? All these request redraws. I hesitate to skip a redraw if egui requested a repaint without like at least scheduling it to be repainted after the minimum time. I think I know how to fix that though. So do we sample the current time at the top? No, we don't. I should probably do that so that's useful elsewhere, right? Top would be right here, which is inconvenient because it would cause more indentation than I want. So if we're beyond the next, or at or beyond the next draw time, we can request a redraw. Otherwise, I think what I want to do is calculate when to this set wait until and do that, right? It would be this part of it. Sort of. It would be part of that. Yeah. So not this max, not this, just the last draw time plus the duration, went over all that stuff. Just that part of it. See if that fixes the it going over 60 FPS if I move the mouse around. Hey there, Epic Unknown. What am I going to do with this program? That's the Epic Unknown. Cool, that fixed it. So now we're capped at 60. I like it. Okay, and if I remove, where is it? The in apps, in app, I think, in redraw, app for redraw. This right here. let's say from milliseconds. So ask, the cube is going to ask the program to redraw 10 frames per second. So if I don't move the mouse, it should drop down to 10 FPS. Hey there, 85 filter. So 85, 10 FPS, and if I move the mouse around, it goes up to, but not higher than 60. Cool, so it's doing what I want. Suppose we'll leave that at 0 for now. I will try to 85 filter, but I thought you would know it by now. You don't know Rust? You rusty in your Rust? I sure was when I hadn't done anything in Rust for several months. Okay. Wasn't there something else on the to-do list? Move the responsibility of updating models and determining a repaint after to some new object, perhaps encapsulating the model's value. So like the behavior of the models and when it asks to be repainted. Okay, let me think about that later. What are the other to-dos? The documentation, public interfaces. Might be fun to get this running on SDL2. Do you still need mem offset? I actually looked into that off stream, and yes, we still need mem offset because standard mem, the implementation of offset of is still unsafe. Bytemuck has an implementation, but it just didn't work for me, so that answers that question. Mem offset still needed. See what lifetimes may be elided or made smaller from this. Okay. Need to like nail the Rust way of thinking. I think one problem with that might be that there are multiple ways to think in Rust, depending on the situation. So maybe you're talking about the Rust way of designing an overall structure of an app, or like at a macro scale, or at a micro scale, like Rust way of thinking about lifetimes and borrowing. Yeah, that. So you think at the macro scale, like how to design an app? Oh yeah, lifetimes of art. Yeah, so you're thinking about both, right? But the macro scale, it's like how do you structure your app? I gravitate towards my main program setting up some kind of app context and doing something with it in a loop. And the setup for that stuff, a lot of it has builder pattern stuff in it. Oh, another pattern that I really like that a lot of these GUI platforms use is interior mutability, which I think a lot of people in Rust frown upon, right? It's sort of cheating in a way. It's where you have two structures instead of one for your state. Your outer one has a ref cell of your inner. In your inner, you stuff all your stuff in there, and that lets you get away with doing things that excuse me, doing things that are mutable. So borrowing your inner state mutably, even though you started out with only a immutable reference. So I can get away with it, and you can get away with it a lot in GUI stuff because GUI stuff is single-threaded. If it's single-threaded, you can get away with interior mutability. Multi-threaded, you run the risk of runtime errors. You can't have two structures, that is illegal. Well, I gravitate towards this in Rust a lot, where you have multi-levels of structures. And another way of thinking about this is the public interface, and this is the private implementation. So we can just make the outer struct public and free to like change the inner implementation at will and not break anything outside. So it's a separation of interface or implementation. That's another way of thinking about it. Actually, in the Rust-Lang book, it is. Cool. Rust-Lang book is a great resource. I lost my place. It was, oh, and I have an error. What? Oh, that happens when I tap on the keyboard too much. Okay, back to the lifetime thing. I put a note for myself here saying, can I simplify this? Like, do I need 2 lifetimes? And which ones can be elided? Well, I guess we could just ask the compiler, hey, can you elide this lifetime? Yeah, answer is yes. So that works. How about this one? Can we elide the model? The answer is no. Okay, how about this is probably a no too. Oh, no, it didn't need me to give lifetime for the render pass. So I don't need this draw anymore. Nice. Okay. Again, we need to elide this one, or we can't elide that one, right? That has to have some relation to the render pass, probably, right? We just have to have the same one. Okay, but can I elide all? Can I like get rid of the name of this? And just put underscore. No, because that has to have a name. The self need to be under the same lifetime. Yes, probably because the render pipeline is owned by self. And can this be elided? No. All right, so that's the minimum. We have to describe one lifetime to bind self, the model, and the render pass together. And I name it render pass because that's ultimately what the lifetime is. It's of the borrow inside of this render pass is how long it's borrowing the encoder for. How good is wgpu compared to bgfx? I don't know what bgfx is. What's bgfx? And good is a subjective thing, right? You mean like easy to use or fast or what? bgfx is a cross-platform rendering library. Bring your own engine/framework style. I mean, it sounds similar. It's got the same backends that same backends that wgpu has. What's it written in? It's written in a bunch of different languages. Mostly C++ and C. Okay, so looking on the surface, I would say that wgpu is more niche, more targeted for the Rust community, and bgfx looks like a more generic, supports a lot of different languages with bindings. So I would imagine wgpu would be faster for Rust than bgfx would be with the Rust bindings, but that's just a guess. So I don't know how easy to use bgfx is. Don't know anything about it. I'm just reading. I just did a Google search to see what it was. I really can't answer that question. What I can tell you is wgpu is a Rust specific library for doing a similar goal. Where's the main page for it? Oops, I think I just closed it. Yeah, can I go to open recently closed? Oh, no, I closed egui. Let's put that over here. I need to organize my tabs. I think it was this page, but I need to go back. So it's for Rust specifically, right? I guess another thing would be it's based on the WebGPU API. I don't know if BGFX is or not. It's suitable for general purpose graphics, so it's probably about the same for that goal, right? Can run natively, so that's the same. They have a showcase just like BGFX does, so yeah. I think that's about all I can say about it. I like the idea of using cross-platform libraries because when I finish writing my program and it runs on Linux, like this virtual machine, I can take my code and run it on on the Mac or on Windows without usually without very many modifications at all. And I just like that idea that I don't have to do any porting. The cost is that the cross-platform abstraction can be less efficient because there's an extra level of indirection. There's some translation that has to go like between this API and whatever underlying graphics API. There's some kind of translation, right? So if I wanted pure speed, I'd probably code directly to the API of the graphics card, that API of choice, rather than go through this abstraction. But then the cost would be I'd have to port it if I go between platforms. Okay, so I finished that to-do item. Let me think. Do I need to do this before the next step, which would be start adding more models in with the physics engine? I don't think I necessarily need to do this right now, so I think I'm going to punt on that. That I can punt. Okay, so this is if I feel like it to introduce another backend. I really don't feel like it today. Okay, so I think we're going to punt on the other to-dos. Ooh, I have extensions that need to be updated. I'll do that off stream. Why make you guys wait on updates to libraries and stuff? Okay, so terminal. Oh, I didn't mean to remove the spinner, so hold on, let's port that. I didn't mean to do that. Let's just drop that change. All this is good. So this is like refactoring, right? Well, refactoring and fixing of FPS cap. FPS cap. So what do I want to say about that? We were drawing immediately whenever egui told us to. Let's shorten this. Which could be faster than our frame rate cap. Fix this by delaying redraw if asked to redraw before the next frame time. How come that's weird. My command W is not always closing the window, it's sometimes just typing a W. Annoying. Back that up off the virtual machine. Request for ultimate performance always leads to raw assembly. Actually, it doesn't end there at raw assembly, epic unknown. For ultimate performance, you move your code onto dedicated hardware. So that's why like the end game for crypto mining is to actually put hashing on dedicated hardware chips, right? The next step after assembly would be like FPGA, and after FPGA maybe no, first GPU, then FPGA, then dedicated hardware. But sometimes assembly is good enough. I think it's time to pull in our physics engine, right? Performance with software. Well, yeah, then if you're staying in the software domain, sure. Yeah, fair enough. Time to pull in the graphics engine. I don't know if I have a tab for that yet, so let's add one. So, ever since over a week ago, I had been envisioning using Rapier physics engine, playing around with this thing. So let's try to do it. So getting started. Easiest way to get started is to read the user guide, play with the examples, Or jump on their head, just Discord and ask for help. So let's open that in a tab. Look at their examples, I guess, in another tab. What's this dot dot? F64? Suppose we want examples 3D. No, is there a start here? Start here. I'm looking for a simple one. I don't know. I don't know where to start. Debug triangle 3. This looks pretty simple. So we have a triangle ground, which is close to the ground I have, which is a rectangle. In fact, I think the dimensions of mine are also 10 by 10. Yeah, here's the dimensions of my ground. Yeah, it's also 10 by 10. Look at that. 10 is such a nice arbitrary number when you want something semi-large. There's a cat lurking around here somewhere. She's trying to get my attention. Her purring does not exceed the noise threshold. Okay, so triangle ground. Rigid body builder, fixed translation. So they put a rigid body at the origin. Insert that rigid body. Then they make a collider out of that triangle. And then colliders insert with parent collider handle bodies. So what's bodies? Rigid body set. So the colliders, a collider is associated with rigid bodies. Pet the cat? I did. Didn't I pet the cat? Maybe my hands were occupied making sure the cat didn't claw my face at the time, and I couldn't pet her. So dynamic box rigid body. I guess by dynamic they mean it can actually move, whereas this is fixed. Okay, so this is make the ground fixed, make our cube dynamic. So here's where we can initialize its position, right? So bodies holds both the dynamic and the static. Okay, so shape it the same way, I guess. Where's the so the geometry is just a cuboid. Okay. So we could start with the cuboid and see how it goes. To have anything more complicated, we want like a convex mesh or whatever. So test, I wonder what a test bed is. Set world, bodies, colliders, impulse joints, multi-body joints, which are all empty, right? And then look at, what does look at? Oh, this is probably visualization, right? And okay, we probably need to look at test bed because it's probably doing visualization. And it's also running the engine. So that's in test bed. Wait, where? Rapier testbed 3D. So what, I gotta go up? Source testbed. Ugh. Really? I gotta look at a 1,000-line thing to see how it works? Can we just have one that doesn't use a testbed? I guess we can go to the about one, the guide, to see how we actually run things. User guide, Rust, simulation structures. All right, so we already got introduced to the rigid body set and the collider set. And we saw that there was also joint set, and that's when you join things together, right? So don't need that at first. Vector where each element is indexed using a handle that combines an index and a generation number. This ensures that every rigid body is given a unique handle. Dedicated page and rigid bodies. They're non-deformable solids. They could, or they might be controlled by the user, like a moving platform. The colliders can be attached to a rigid body to specify its shape and enable collision detection. Rigid body without a collider attached to it will not be affected by contacts. No shape to compute contact against. The cat's running around in the background, trying to get my attention. Over here. I'm over here sitting at this chair. Oh, you brought me something, huh? Here. She brought me this little mouse toy. Look at that. Look at that. Just like a real mouse. Brought it to me in her teeth. And she went and chased it when I threw it. Okay, yeah, so there's rigid body set, and then you make a builder. You give it its physical characteristics. You can, okay, here's where you give it some initial velocities. So we could give it a spin with an angular velocity vector. You can give it a gravity scale if you want. You can tell if it can sleep. The default's true. Okay. Cat is not wise to play underneath the chair. She really wants attention. The only ones that are required are to either make a new builder, to either fix it or make it dynamic, or make it kinematic. Then to initialize, what is to initialize the builder? I guess that's this new. Is that what that is? Weird. You're gonna get run over. She's trying to get my attention by going underneath my rolling chair. Not the smartest cat. Don't want to run over her little claws. Okay, so 3 types of rigid bodies. So dynamic, fixed or kinematic, position-based or kinematic, velocity-based. Okay. Let's get ready to introduce the physics engine. So in cargo toml, we're going to pull in rapier because we haven't yet. Version are we on? 0.17. Okay, what's the problem? Oh, it needs to be in a string. Nice that I get a nice red block there to tell me if I screwed up the cargo. All right, we have a physics engine available. So where should it live? Probably with this in the app, right? So why don't I go ahead and add whatever I need to the app for that. Okay, in that example of not the test bed. The test bed was too complicated for me. I don't like looking at a 2,000 line long thing. Go back to the triangle, the debug triangle. So I think these are the things we want to keep in the app, right? So we have the rigid body set, the collider set, and the joint sets, impulse and multi-body. Kind of feel like these should be kept separate. Here's our app state. So what if I have like physics world, and in that we put the rigid body set bodies. Do I have to actually say prelude? Prelude? I don't like the prelude. Can we just remove prelude? No, we can't. It has to be prelude. Well, shoot. Let's look at the API reference to make sure. Re-exports. And we actually have algebra re-exported to us. So they used algebra internally. Well, that's convenient. Modules. Whoops, wrong key. Would it be dynamics? Yes. So a more correct one would be dynamics. There we go. I don't like messing with the prelude for libraries. I feel like it pollutes the namespace. Like, yeah, I don't know. It's a preference thing. Okay, back to this collider set, right? Colliders. Again, the prelude. It's probably also from dynamics, right? Nope. Collider set is not from dynamics. Also a useful exercise, I think, to actually look and see where things are in the hierarchy of the physics engine. So colliders, what would that be in geometry? Yes, that's geometry. So we get the rigid body set from dynamics, we get the collider set from the geometry sections of the engine. Impulse joints and multi-body joints. Impulse joint set. And multi-body joint set. All right. Guessing that these are all in dynamics also. And I am correct. Okay. So we'll add this to our inner as in world or physics world. How about just physics? How about we just type it all out completely? Physics world. Okay, so we'll need to initialize it down here. Bodies. C85 filter. Gotta do some chores. Good luck with the chores. Okay, so this was like this all involved just making new ones, right? Yeah. Pulse joint set new and multi-body joint set new. Okay, so now we have a physics engine. We're just not using it. Okay, so back to their example, right? They made a rigid body and a collider for everything in the world. So yeah, I just don't like the structure of this example. Like, shouldn't there be an example that doesn't use a test bed? I'm not the biggest fan of this. Because this just says how to set it up. It doesn't actually say how to use it. And I hate looking at a test bed to see how to use something. Maybe there's an example that doesn't actually use the test bed. No, I think they're all going to be structured the same. So maybe the examples aren't the best. I'll park it on triangle 3, I guess, and then we'll go follow their guide. So, for example, do they actually build up to something easy? Basic simulation example. Here we go. Let's follow their basic simulation example. So the ground actually doesn't need a rigid body. It just needs a collider. Okay, good to know. So there's a rigid body and a collider for our cube. Integration parameters, physics pipeline, island manager, broad phase, narrow phase. Do we need to create all those things too? It looks like we do because the physics pipeline step takes all of that junk. Okay, I'm glad I made a structure for all of that. To make it easier, what if I just copy this? Oh, all of this actually. Physics hooks also? I'm not sure what that is, but copy this part for now. Okay, let's just turn this into initializers. Man, a lot of junk. Okay. We already have the impulse joint set and multi-body joint set. So we're missing these 6 things. integration. So we'll have, let's go to this, go to the end. That. Import the things. All right, and get rid of the word prelude. So let's assume that they're all in dynamics. Okay, these ones are not. These. Hot phase, narrow phase physics pipeline. Okay, so where is broad phase? Under geometry. But the physics pipeline is not. Where's physics pipeline? Under pipeline. Okay. Got all the junk that we need. Oh, so ultimately, in our game loop, we're going to want a step. And then that will update the rigid body so we can get its characteristics. And I'm going to have to tell it how far we're stepping, right? Where do I tell it how far we're stepping? Guess we'll find out. Kind of want to know before I find out experimentally, though. How about if I look at the pipeline step? Executes one time step. This is the same as step generic, except that it's specialized to work with rigid body and collider set. Okay. So what's a step? Relies on a time stepping scheme. Its forced computations use two solvers, a velocity-based solver, a position-based solver. Okay, but how far is a step? I don't know. I wish it would tell me. Just tell me. Simulation structures, I guess. Timestamp length is in the integration parameters. Okay. So we want to look at integration parameters. DT, I guess. Timestamp length, default 1/60. Okay, so I'll need to customize it to match my update rate, I guess. What happens if I don't update it at 60 frames per second? I guess that is if there are sub steps with CCD, right? The CCD is when you do like little micro steps when something's moving very fast. That's what I remember reading about this before. Okay. Let's remove this out so I can customize it. Set up physics engine. Let physics world equal that. Integration parameters dot dt equal 1 divided by max frame rate, max draw rate. As F32. Better way to do that? May truncate. That's fine. We'll allow the truncation. That's not a... Wait, what? Attributes on expressions? That's not an expression, it's a statement. Where would I move that to make it not a statement? The top here? That's sort of a big hammer for a small nail. Can you ask me about anything? You can ask, but I might not answer. So I'm not gonna, probably not gonna answer personal questions, and I can't talk about work. But if it's something I can answer, I'll try. No, not personal. So why don't you just ask? You wrap everything together. Clean code, horrible performance video. Okay. What's my honest take on clean code, horrible performance video? My take on clean code is that for me, it's hard. So what I usually do is I first focus on getting something to work, and then after it works, then I try to make it clean. And so it's make it work, then I had this written down so that I wouldn't forget it, but now I don't remember where I wrote it down. Make it work, make it readable, and then make it fast. I got to define what clean. I think if it's readable, if I can come back to the code a year from now and read it and understand it, then it's clean. Also, it's clean if we uphold a couple design principles. Okay, the really important design principles are SRP, single responsibility principle. Right, that's one. In fact, it looks like we have a shortcut to all 5 of them here. Sure. Single responsibility. Some of these are more important than others. My mentor would always joke about the Liskov substitution, saying that they only put that in there in order to make the acronym a word. Really, it's sort of a silly addition to it. The other 4 are important. The Liskov substitution is really weak. Single responsibility, open close, interface segregation, and dependency inversion. So if you follow those 4, I think your code is pretty clean. Clean equals application with no features. Well, with no features, it's easy to adhere to all 4 of those. Following the solid principles affect performance. They're usually orthogonal to performance. Performance is usually about optimization. You can still adhere to all of these principles and optimize. So once you have gotten a class to have a single responsibility, then you optimize that class. So it might be that you can't get enough performance without like breaking down the barriers between things and like tighter integration. But I've never had to do that. And that guy in that video totally changed your perspective on how you write code. Which video? Yeah, I think we don't know what horrible performance video actually means. We need to know what that means. Send that here. I'm not going to be watching a video. Yeah, I'm not going to watch the video. Sorry. I got to do my. I have my own stuff to do. I was going to say, like, if my Discord was open, you could post there and I could read it there. But you know what I'll do is I'll take that link and put it in my notebook to watch later. And if you're back in the future stream, I can let you know what I thought. So where do I want to put this? I have a to-do thing. To do, look at later. Here we go. I'll put it in here. Look at later, and I'll put your name there. Look at that later. You're disappointed after watching that video? Well, now you have me intrigued. Disappointed at what? The video or the industry or I don't know. Why would you be disappointed after watching a video? I'm guessing you meant you were disappointed at the video. Then why would you want me to watch it, I guess? You want me to be disappointed? Disappointed at your beliefs about clean code. Well, that's a healthy thing, right? If you have some preconceived notions and watching something helps change that, then hopefully your worldview is getting wider and you're incorporating other ideas, and that's a healthy thing. I wouldn't be disappointed about that. I'd sort of be relieved that my narrow-mindedness has been maybe corrected somewhat. Kind of clickbaity video, don't lose sleep at night over retail performance. I think a good general rule in life is don't just accept anything that you're shown or given. You gotta get a second opinion. So if you watch a video and the video says, all programming languages suck except for Rust. Number one, whenever someone makes an absolute statement like that, you should always, like, the red flag should go up saying, wait a minute. That's totally like challenging someone to knock it down. Number two is like, especially if it doesn't jibe with what your experience has been so far, you kind of want to like question it and say, well, does this person have a bias or an agenda? So a lot of people sometimes have a bias or an agenda. So they might be inflammatory because their agenda is to get you to buy some product or try or adhere to their way of thinking. And all you really need to do is look for another video on the same subject and then balance the information from both videos. The video shows how using virtual functions in CVP and using polymorphism and other patterns significantly slow down performance. Okay, well, find another video that talks about polymorphism and performance and see, does it agree? Or does it have different insight? You might also measure it yourself. Sometimes, like, if something is not hard to experimentally verify or disprove, you should just do it. If they say it slows it down, make a program that measures performance of a small function and see if it does. Definitely narrow focus, and that might be considered bias. It's also sometimes the context matters. So it could be that its performance is bad on an embedded platform, but maybe it doesn't matter on desktop PC, right? Maybe it matters in a game where you have a budget of 1/60 to do all your work. So what is that, like 20 milliseconds to do all your work? But maybe in another application you don't have that tight deadline and it doesn't matter. So yeah. Context matters. Look for bias. Look for agendas. Don't be disappointed if you get information that doesn't jibe with your experience, and look for second opinions. I guess that's my advice. It's factually true. It doesn't mean you should throw away C++ OOP. So my personal take on virtual functions and polymorphism is that I expect it to slow things down, but that's a cost to gain the benefit of more flexible typing at runtime. So a perfect example of that would be in my main program, I have, look at that. It's a bunch of vtables. Look, here's my vtable. I have an abstraction that's through an object interface, right? And I'm making an abstraction. Every time now I go through this window object, I'm making a vtable lookup and a function call that maybe I didn't need to if I knew at compile time which implementation I was using. But the benefit I get is my program can flexibly go between two different backends without needing to be recompiled. You requested to watch the video? Sure, I'll watch it. Yeah, when someone gives us like a very broad statement, especially if it's very polarized, you should always question like, is it like very few things in life are universally true like that. Usually it's true in a subset. It depends on the context, right? So the question should rise in your head like he's probably right but in what cases? And that sort of should kind of narrow down where that information is useful and true, but then not preclude you from like having a different view in other contexts. Thank you, Utsby, for that perspective. Okay. I'm customizing the integration parameters because our update rate might not be. Yeah, because I plan to basically update the physics engine in the redraw. So I want to tie the rates together so it's physically accurate. That means basically I'm always going to draw at the max draw rate. I guess unless maybe the physics engine says that there's no updates. If it can tell me that, then we can skip the redraw, right? Where was the complete example? Kind of lost my. I know where it was. It was back in the getting started. Right here. Okay, I got like another hour and a half-ish. In your opinion, 90% of apps probably don't need crazy performance anyway? Yeah, so again, my order of operations is first make it work, then make it readable, then make it fast. Sometimes you don't need steps 2 or 3. Sometimes you just need something to work and you don't need to read it because it's a one-off effort. You're not going to need to understand it a year from now. So you just make it work. Don't worry about making it clean. Don't worry about making it fast. Most of the time, though, you'll want at least the first 2 steps, and then you evaluate, is it fast enough without optimizing it? If so, then you don't need to worry about all the complexities of optimization, picking the right thing for speed. You don't need to worry about that. Just use what is familiar to you and allows you to accomplish the first 2 goals, which are make it work and make it readable. Think about it this way. If you have a goal in mind to climb a mountain, right? But hey, you also like to look good. Well, ask yourself, when you climb to the top of that mountain, is there anyone else going to be there to see you? If not, then why do you care if you look good or not? Right? If you like to look good, but no one's going to see you, why does it matter? So just climb the mountain. Now, if someone tells you that when you get to the top of the mountain, there's going to be a photo shoot, now you want to worry about when you're going to climb the mountain, how are you going to look good when you get to the top? But wait to see if there's going to be a photo shoot before you worry about that. So you can say Toyota is much slower than the Ferrari, would actually factually true, but most people don't want a Ferrari. Most people don't want Ferrari and get job done with Toyota. I think sometimes you just don't need the Ferrari. Another perspective is like, what's going to be faster to cross the street, the Toyota or the Ferrari? That's not a good analogy. How about this? What's faster to cross the street after a red light? A Toyota, a Ferrari driven by an amateur, or a pro bicyclist? I'm going to say the pro bicyclist is going to get across the street first. Maybe the Toyota, because the amateur and the Ferrari is going to struggle with the gear shifter and they're going to be the last to cross. So it depends on the job. Now, if the job is to like race to the end of a kilometer, I'll bet on the Ferrari, even if it's driven by an amateur. Because once they figure out the gears, they're going to blow away the Toyota. Make it work, make it readable, make it fast. I had that in my notes somewhere. What if I look for make it work? Unfortunately, I can't search for phrases. My own notebook. Fast? Okay. Can't really search for phrases in my notebook. And I have an old... Oh, I do have an old notebook. I'm not very well organized, so not finding it. Anyway. Where in my old OneNote notebooks, and hey, they're playing with scissors, I'm looking for where I wrote down the motto of make it work, make it right, make it fast. That's what it was. It was make it right. So it's make it work, make it right, make it fast. In those order. There. First make it work, then make it right, then make it fast. Oh, did I have it in the screen in the info tabs below? The YouTube link shouldn't be broken. I did change my Twitch name, which causes a lot of old links back to Twitch to be broken. It used to be Raimu8354, but then I was able to grab Raimu. Oh, you clicked something else? Yeah. Yeah, the links that might be broken are some old links back to Twitch, but the YouTube one should work. Yeah, there's a lot of things to copy here, so I'm just going to copy them and not write them from scratch. Okay, so we do everything in redraw. So this is all the egui stuff. This is our model stuff, so I think this is the place where we're going to do it here. Step the physics engine. Simulate one time step. You don't agree with a whole lot of make it work, make it right, make it fast. You prefer thinking code is optimized for? That's fine. It's just a philosophy that I use personally. And it's been working for me for a while, so. To each his own? Okay, so physics life. That's self.physicsworld.physics pipeline. Gravity. Good question. What's gravity going to be? Vector. Vector. What does it actually want? It wants a vector, which is a Perry 3D vector, which actually goes back to an algebra. Okay. It wants an algebra vector. And I forget, can I just start with a array and go into? So down would be the negative y direction, right? And isn't it like 9.8 if it's in meters? Or am I remembering wrong? Hey, look, it works. You can use an array and go into. Into is kind of neat in Rust because it says, take this type and just try to fit it into what it needs to be. You're working on the MVP to prove people think my project is worth paying for? You mean prove to people that your project is worth paying for? There's no way of making that pretty or fast. Depends. Are they going to look at your code? I guess yes, right? Depends on what the people are and what their sense of worth is. If you're showing it to a bunch of engineers and they're going to want to pay for it, they're probably going to want it to be like structured well, and they won't care if they'll get 1 million users. But if you're trying to prove it to like CEOs, they're not going to really care what it looks like. They want to know how fast can you do it and how much money can I make from it. So worth is relative to the audience, right? Selling a service, not software. Okay, but are you selling it to CEOs or are you selling it to customers? Because they're going to have different concept of worth. Customer is going to care about like what features it gives them. CEO is going to care about how much money they make. No, she just wants to play. The cat's like bothering everyone in the house, and I'm like, yeah, she just wants people to play with her. What is the USP? USP. Universal sales principle? Customers. You're selling it to customers, so it's going to be about what does it provide them? What usefulness is it to them? Yeah, they're not going to care about how it looks, and they might not even care about how fast it is. If it's slow but it's really useful, I think that's most important, right? Unique selling proposition. So I was totally wrong. Gravity's 9.8. So I did get it right. Yeah, so I was trying to guess from old memory, like what gravity is in meters per second squared. Have I tried Vim? I used to use VI, and then someone tacked on an M to it at some point. So I'm familiar with Vim, but I never learned the keybinds or never learned how to set up the keybinds so that it was comfortable for me. So I can navigate through it. I know how to quit it, so that's the number one thing. It's the number one goal with Vim is to learn how to quit Vim. But I'm not comfortable using it day to day. Saving time is a good measurement for worth. For customer, if it saves them time, yeah. You don't know if your customers think your product is worth paying for, you should ask. That's what most big companies do. They sample their customers and they ask them, hey, is this worth paying for? But if you can't sample your customers, then I don't know. What does a small business startup do? They like ask their friends first and say, hey, if you were my customer, would this be worth paying for? Yeah, all right. So I'm getting into the weeds with that discussion. I need to get back to this. We're going to end up doing a lot of this. So what if we encapsulate this into the physics world itself? So in other words, take this and kind of move it up and have a impl physics world. And just have a step there. And paste that there. And then I can just put self in front of everything. So in front of all the things, right? I called that bodies. Call that colliders. I called that impulse joints. Multipody joints. Okay, now I need to figure out what is physics hooks and what is event handler. Physics hooks. What is a physics hooks? User-defined functions called by the physics engine during one time step in order to customize its behavior. Oh, okay, so we get a callback if things collide. And this is required somehow? Dyne physics hooks. So what does that mean? They probably have an implementation for, so that's clever. So you can provide a unit and then they say there's defaults. I like that. I'll have to remember that trick. In other words, I can just put nothing here. And it just works. And then what's event handler? Trait implemented by structures responsible for handling events generated by the physics engine. Oh, okay. So they also have a default. So how's that different from physics hooks again? Oh, so the latter is like when things collide. The former is like filter things out before applying collisions. Like you can say, I don't want these two things to collide. Okay. Yeah, it's like while it's solving it. I get it. I get it. Either way, though, I don't care about those right now. Cool. So then it's simpler. I can just say self physics world step. All right. So I still need to actually put my objects into the physical world and then get, instead of updating a rotation and all that based off of some arbitrary angle, based off of time, we're going to want to actually get it back out of the physics engine. So I'm wondering, this rigid body that we add, when I put it into the set, it's by handle, right? So I can copy. Is that handle copyable? Rigid body. Does it implement copy and all that? You can put a user-defined data? Interesting. Blah, blah, blah. When it's clone debug, default, deserialize, into serialize. Okay, so rigid body set. Oh, okay. When we insert the rigid body into it, it owns it, and then we get a handle back out. Okay, and probably we can use the handle to grab something, right? Yeah, we can get with the handle to get an option. We can borrow the body back out. Okay, so the set is going to own the rigid body. We get a handle when we insert it. The handle probably is copyable, right? Clone, debug, default. Really, it's not copyable? Shouldn't it be? Oh, it is copyable. Okay, so it's a trivial value. Okay, I got it. So that means that I should be able to, like, when we set up our objects in new, we create our 3D models, I should be able to like insert them into the physics engine. So we probably want to set up the physics engine first before we set up our models. And then when we create the model, before I put it in there, this instance should like get a rigid body. So how would I do this? I need to make a rigid body for it and add it to the rigid body set, and then get the handle back out and hold on to it. So I guess that would be like, I kind of want something like with rigid body. Except for there are two kinds of rigid bodies, right? No, there are two kinds of colliders. Right, so I'll like want with collider. And then the cube will also have a rigid body. And both will need to borrow beautifully the physics world to add their information to it. Do you have a moment yet where you thought, damn, this would be better done in C++ than in Rust? Early on when I was learning Rust, yeah. But nowadays it's usually the other way around. Usually I'll be working in C++ and I'll be like, man, this would be so much easier if I did it in Rust. The number one thing is, for me, is searching for something in a container. I hate that in C++ you have to do a comparison with the end iterator to see if it's in the, if the iterator is actually, if you're looking for something in a container, you have to like get the iterator for that item and see if the iterator equals the end iterator. And I think that's so clumsy. Marching forward to a bright future, not looking back. Well, the problem is that I'm only using Rust in my hobbies. So, like, I do, well, I'm not supposed to talk about work, but like, I guess it's okay to say I use C++ at work so that I'll be at work and I'm thinking, man, this would be so much easier to do in Rust. I wish I could use Rust. So the ground is going to have a collider but no rigid body, right? My idea is that the model should know best how to represent itself in the physical world. In fact, I could just combine this, right? What if we call this, what if I just let the model be tied to the physical world from the start? No, I'll reserve the ability to have a model not be in the physical world. So with physics, I guess. What I'm planning to do is it'll be based off of the type. So that's we don't actually, the instance doesn't know its types. That's the problem, right? We don't need this draw order anymore, do we? Well, no, I do need it later if I have transparent objects. Actually, I don't even need it then. Really, the draw order should depend on where the camera is. I should probably get rid of this draw order. It doesn't make sense. But not now. Okay, trying to think what code should be responsible for knowing how to represent the model in the physical world. I guess I can put it here for now and then move it later. Okay, so to do that, what would I do here? It would be like with rigid body. So we would, this is not, this doesn't have a rigid body then, but there is a collider. So we would have to make a rigid body first. That's self.physics world. bodies dot insert, and it was rigid body builder, right? A cool name. New dot, oh, needs a body type. Rigid body type. Cube is dynamic, right? Okay. And then we got to build that body, right? At the end. Okay. With rigid body. There. And then need to define that. Hey, how's it going? Undeclared X? Good morning, Ramey. Trying to add a physics engine to my code. I haven't shown this in a long time, so people might have joined and have no idea what my program actually does. So let's run it. We're just playing around with libraries in Rust. So some libraries I had been playing around with was low-level graphics. I'm drawing this colorful cube with some ground underneath it. And I'm also playing with egui, which lets me do like graphical user interface things on top. So the third major library I'm starting to work on today is physics engine called Rapier. And just to play around with it, my thought was to give this cube and the ground underneath it actual definitions in a physics engine, and then let the physics engine kind of sort of drive the positions, rotations, and momentum of all these objects. So we'll see the cube actually fall and bounce if I do this right. And right now I'm sort of tying in these model instances with the physics engine, and the model instance is basically the information about where like the cube is on the screen right now, or in the world, how big to draw it, and like how it's rotated. There's also draw order, but we don't really need that anymore because I implemented a depth buffer, but that's not important. So just to tie in the physics engine, we'll be assigning it a handle so that we can use that handle and look it back up later when we are simulating the world. So this is going to take a rigid body handle. Rigid body handle. Self.rigid body. We'll sum rigid body because it's going to be optional. Okay, oop. So I'm really adding that to the properties of the model instance like that. Option means that we might not have one, so that allows me to say that initially model instance has none for the rigid body. And I know later we're going to need to get it back out, right? So we're going to need to get it back out. But it's immutable. Self.rigid body. Actually, this is an option because there might not be one. I get a little frustrated sometimes at my bad skills on the keyboard. All right. So we want to give it an this initial position really moves into the rigid body. Yeah, so to drive this work, what I'm going to do is, knowing that the physics engine takes over the position and stuff, I'm going to go to the model instance and actually remove the Do I remove the scale also? No. I'm going to keep the scale because that applies to how it looks, but rotation and position, we'll let that move into the physics engine. So I just drop it completely, right? Drop these. Drop the at position. And drop the update rotation. Okay. So the render needs to know the rotation. So that means we'll have to be able to get it. So that means we'll need the draw to borrow the physics engine, right? Well, the rigid body set. So bodies, rigid body set. So the way we'll get the rotation then, do this in extra step here, instance body. So if something doesn't have a rigid body, it won't have a rotation or a translation. So instance body, actually that means I'll do it this way. If let instance body equals instance dot rigid body, then we can assign the rotation and translation. What do I do about the ground though? I guess the ground is anchored to the, it doesn't have a translation. That's right. Physics, yes. So rotation. Well, we have to get the actual body out. So that's bodies dot get with the handle, and that also gives me an option. So this would be like a dot map. Handle to bodies dot get handle, right? So now it's oh, it's an option. It's not map then, right? Wait. The handle is a rigid body handle. It returns an optional rigid body. Why do I have a double option? Shouldn't have a double option. Why do I have a double option? Map goes from one option to another. Shouldn't make a double option. It's a double option. I'm really confused. Without this part, what is the type? An optional. Oh, wait. Without the if, what is it? An option. So it's just not showing me the right type here. I think this inlay hint is just wrong. So assuming that it's actually a rigid body, the rotation is instance body dot rotation, right? Okay. How do I get the rotation back out of a rigid body? Just rotation. Rotation. But if I need to convert that into, oh, it's a unit quaternion. Oh, that's exactly what I want. To rotation matrix dot to homogeneous. I don't know. I still don't understand why it's a double option. Map is supposed to... stop it, watch. So map is supposed to return me an option. The if let... Oh, I know why. Yeah, sum. I keep forgetting that. Now it makes more sense. But there's still another option. So why am... I thought rigid body returns me an option. And then map maps one option to another, right? And then get returns me an option. So then why is there a double option here? Am I not understanding map? T to U, converting to another type. Yeah, I mean, that should work. What am I doing wrong there? Anyway, get this other code done first. Translation. Translation, it is translation. Gives me a vector, 3D vector, so translation. So I kind of want to move this out, right? So it's like let the instance rotation and instance translate. I don't like the terms I'm using. So if there is no rigid body, it's just going to be a unit quaternion, right? Identity and a matrix identity. Matrix 4 identity, right? Takes because I'm returning option T rather than the T inside the map. Inside the map. Bodies is, or the get takes a handle. It had no trouble with that. It returns an option. Oh, I see what you're saying. Map doesn't want an option. Map wants an actual value. So it's not map that I want. One of the others, yeah, thank you, Intahimos. One of these other ones that I want, right? Is it something that internally maps to an option T? Is it or else or and? It's and, isn't it? Not and. It's if it's something, then I want to take that thing and turn it into something. I think it would be and. Returns none if option is none. Otherwise returns option B. But I need an option B that's calculated from the sum. So it's not and that I want. Is it and then? It's and then. It is. Found a reference. No. Wrong thing. There we go. I fixed it. Okay, what's wrong with this type? They're incompatible types. Oh, it's because this should be a comma. Expected a matrix. Oh, Yeah. Gotta do this. Well, I can do this later. There. Oh, still no. One's a borrow, one's not a borrow. So dereference. Okay, so these are what, giving me all 32-bit values? Yeah, F32s, and I prefer to operate with 64 bits. Actually, doesn't it go down to 32 bits at some point? I can't remember now. Oh, perspective 3 deals with 64-bit. No, it's a T. So I think it's because the on input they were all 64-bit. Oh, what did I have originally? Okay, originally this was what? They were 64-bit. Okay, yeah, I'm mixing 64 and 32-bit values. That's the problem. The best way to do this. The physics engine is definitely 32-bit, right? Okay, it depends on the feature that I enable. Can I just cheat and turn it into 64-bit stuff? Whoops, too many quotes. It didn't like that. Wait, what? There's no such feature? Whoa. I thought that's what I was just looking at. Oh, it's the Perry 3D. Okay, forget it. I don't know what feature we have enabled for Rapier 3D. I'd have to look at its cargo toml, right? Okay, it's using default features of that. Okay, like maybe I just can't. Yeah, maybe I can't use 64-bit. So in the physics engine, it all has to be 32-bit, I guess. So I guess the easiest way would be get it 32-bit to begin with. So that would mean can I go between two kinds of matrices? Can I go do like an into here and here? Doesn't know what to go into. Type annotations needed. Dang it. It will have to be specific here, right? Unit quaternion of F32s and something else. Okay, we still, oh, 64, sorry. We can't go between, oh, still needs annotations. Why does it, is it because of this? Okay, we can't go from 64-bit quaternion, from 32-bit to 64-bit? Other types. Well, that's weird. That's hokey. Shouldn't they allow me to just, I guess I can do it element wise. Okay, we're doing it element wise. Q equal this. Or actually, I guess we don't need to dereference it. We can just return unit quaternion. It wants a 3 by 1. It wants an axis angle. Axis angle. Dang it. Dang it in algebra. That move over to there. Go there. Okay. Do I have a tab for an algebra? Probably not. Oh, I do. Okay, so quaternion. From quaternion. From a quaternion. Maybe I can convert quaternions between different formats and make it a unit. Back. So fundamentally, it's this T, right? And if I wanted to go between two different subtypes of T, and I guess this doesn't implement that. Does implement a lot of things. Huh. Interesting. There's a separate F64 version of Rapier 3D called Rapier 3D F64. Yeah. That's another thing I could do, but kind of like sunken cost fallacy tells me I've already gotten this far. I only need to go a little bit further. To keep the fist extension 32-bit and the graphics 64-bit. I mean, it shouldn't be too hard to do. I'm wondering if the problem is that quaternion you can do it, but not unit quaternion. So can I take that rotation and then like get the quaternion out and then do an into? Can't get a unit quaternion 64 from a 32-bit quaternion. But can I turn it into a 64-bit quaternion? Let's see if I can do that. So if that's a Q32, can I get a Q64? Quaternion F64 Q32 dot into. No. Can't do it. And can't do it by dereference first, right? I do it this way. Be explicit. I figure this out. I have to dereference. Okay, still can't do it. Can't convert between 32 64-bit quaternions. Well, that's just stupid. So how can I make one of these then? I can just fill the constants in, looks like. So can I get the original constants back out? I guess it's what? I don't know the order of them. W-I-J-K. Okay, so it's W-I-J-K. Okay. And then that in front of all of these, it's please double their precision. Right? F64 parentheses. It's from. Okay, and then I should be able to put Q64 into there. Oh, right. I have to like do normalize or something, right? Not normalize. It. Too many methods. Okay. There's something on this page that says unit. I can't search in the page. Oh, it's Control F, not Command F? Okay, fine. Unit. Why does it say unit quaternion there? Oh, you would think that I could just normalize it. and it would give me a unit quaternion, but it's not. How does unit actually work? So it's new normalize? Or do I just do into again? No, it just doesn't like into on its own. Assuming it works. Rust and common sense not always the greatest pairing. Hi, Dusty Posse. Not Rust, it's an algebra, and I'm not used to it. To get a 64-bit quaternion to be a unit quaternion 32, to be unit quaternion 64, that's what I'm struggling with. How do I get from that type to that type? Can I do new normalize U64? Oh, thank goodness. Reverse it with the unit everywhere. The problem is that this didn't work, right? I would have liked to have done this and not do quaternion part, but that didn't work. But unit quaternion didn't have a new that took the single elements. That was the problem, right? So I had to get the quaternion out of the unit quaternion, then convert their elements, and then put it back in with new normalized to make it a unit again. Ah, what a pain. Anyway, I still have a problem here. I think my types don't match still. Okay, so I still have a 32-bit matrix here. Is it the translate? Like it is, so I guess I can put that here, matrix 4. F64. Am I going to have another type conversion problem? Yeah, it's this one. Oh, it doesn't want to go upcast from 32-bit to 64-bit matrix. What a pain in the butt. Well, how about we can at least translate the vector first, and then we can do the into later. So that would be this dot into. It might not figure that out, but so we just remove this into. This is a vector 4, vector 3, vector 3. Translation. Yeah, we don't want to I actually just want, oh, I want that to be outside here. So this should just be that translation. Oh, let's see if into works there. Wait, that should be a vector. Oh, this should be vector. This should be 0. 0s. This type implied, whoop. Be explicit in the type until I make it work, and then I'll fix everything. It still wants it to be a matrix. Why is that? I told it to make it a vector. Translation is, oh, because a vector is a matrix. That's why. And it's just basically like saying it can't go from a, it's the same problem. I got to do vector 3. They, I'm tempted to extend these types to do this myself, but they want me to do this. Ah, shit. Let b 32 equal this. B 64 equal this. X, Y, and Z. A pain. Mismatched types. Expected a reference found a struct. Fair enough. Okay. Now what is it telling me here? Binding's name is too similar. Oh, F you. Can I at least get rid of the explicit types there? Okay, I can get rid of that. So then I can kind of, well, translation. Pain in the butt. Hey there, A squared. You shut Clippy up about that one? It's not useful when there's math like RGB. Yeah. Well, I did it because it's temporary, because I think what I want to do is I want to extend these two types so that they can upcast from 32 to 64 bits. I don't know why they don't have it, but it should be a trivial operation to go from a 32-bit float to a 64-bit float. It's not losing precision. Why doesn't it just let me do it, right? I had to do this manually to actually get it to, so actually now I don't really need these types, right? These should work without types annotations now. Yeah, it's, the other problem was I had to get the quaternion out to get to its elements and then put it back into a unit quaternion. I kind of want to make another upcast thing for that. Let me put a to do here. Extend or teach. I like to say teach. Teach algebra how to upcast F32 to F64 in various types, such as a matrix and quaternion. Well, also how to do it with unit quaternion. Let's say unit quaternion. So I could just encapsulate this junk in like an extension of some kind, right? An impl of some kind, or a free function. One would hope that floats just worked. Yeah, that's what I hoped. Anyway, so the whole purpose of this is that if the instance has a rigid body, we're going to get the rotation and translation from the physics engine rather than we're just assuming if we don't have a physics engine, we don't need to rotate or move it at all. And the scale we still get from the model itself. The physics engine doesn't know about the scale. I'm getting a raid from Booyah Grandma. Thanks for the raid. It's a Booyah Grandma raid. Welcome, raiders. I'm working on this little playground here. I'm learning a couple different Rust libraries, and I'm not really working towards any specific goal, just trying to learn the libraries. And I got two things working, and I'm trying to add a third thing. So the two things I got working is I can draw graphics using wgpu. Number one. Number two, I got the GUI elements to draw on top of that using egui. So that's the second library. Third library I'm working on today is called Rapier, and it's a physics engine. So I'm trying to add physics to these. Rather than having this arbitrary spin to this cube, I want the cube to actually look like it's real and it's falling and bouncing around. That's what I'm working on today. This type here, render, is like drawing the cube, for example. And in order to draw it, we have to know like how big to make it and how much to rotate it and where to put it in space. And I'm in the middle of moving that knowledge, that responsibility, over to the physics engine. So that's what this, where is it? This rigid bodies is borrowed from the physics engine. So we peek into the physics engine state to see where is this instance of the cube, right? And how much to rotate it. So it's rotation and it's translation. And I had to do a little funky conversion here because the math library I'm using isn't smart enough to know how to go from 32-bit floats to 64-bit floats for each of the components of a quaternion or a vector. And so I had to do it manually, which was a pain in the butt. But I did it. So hopefully now, instead of just drawing it arbitrarily in space, it's going to actually get it from the physics engine. And as long as I provide a colliders for the cube and the ground, the cube will bounce. Actually, without colliders, it should work now. It just will fall down through the ground, right? That would be fun. Let's see if it actually works. Oh, actually, I know it's not going to work because I have errors. Need to fix the errors. Just needs 2 more followers to get to affiliate. Creating a great game called Alpine Lake, and you're working on it today? Oh, nice. You're impressed by this low-level understanding? I try to get the low-level understanding because I'd like to know how things work. Even if I'm using a library, I'd like to know at least how the principles of the stuff. Right. We have a problem in that I used to put the position directly in the instance, but I need to put it into the physics engine now. So I think the way we do this is, instead of just building it, before I build it, we give it a position. So let's move this out. Let cube body equal that. And then we'll put cube body in there. So that before we build it, we can, there should be things for like position or something. There we go, position. Is position the right one or is it translation? Translation. So sets the initial translation. So that's going to be this vector here. Right there. So we don't need that anymore. Okay. And then, should I give it an initial rotation? Rotation. Okay, so they didn't have a initial rotation before. Let's skip the initial rotation. I'm just thinking if I don't rotate it and it's gonna fall, it's not gonna look cool. It's not gonna have a cool bounce because it'll already be like level, and so it'll just kind of drop and stop. But we can at least see it fall. Then I can give it a collision with the ground, and then we can rotate it to see a nice bounce. Okay, the ground. I can't give it a Z translation right now, right? Why did I give it a Z translation of -5? Why did I scale it by half? I don't remember, but I can just bake it into the ground vertices. So subtract 5 from the Z coordinates. So that's 5 on all of these. And I don't know why I scaled it down. That shouldn't have to do that. Let's forget about scaling it. I'll remember that I did that by doing that Actually, we can use the scale. The scale's fine. The scale's fine until we have something drop off the edge, and then it's not going to look right. So keep that in mind. Fix the other compiler errors. Okay, draw now needs the rigid body set from the physics engine. So we have that here. And I wanted it to be after the model instances, so right here. So that's self.physicsworld.bodies. Okay, and just chasing the compiler errors here. Update rotation. All right, so this stuff we don't need to do anymore because we're letting the physics engine handle that. All right. Means we don't need the elapsed time. Cool. I still have 6 warnings. What are the warnings about? Probably things I imported and I don't need. Get rid of that. 4 more warnings. We never needed to get the rigid body handle out. Why is that? Why didn't I need that? Yeah, why not? I should have needed that in the renderer. Yeah, I called it right there. Why is it saying that it is can return without recursing? Oh, that's a bug. It's not supposed to call itself. Good warning. Don't call yourself. Yes, extract from the actual data. Hey there, Krasner. Yeah, long time no see your chat. Should I just go for it? This could go well or could go horribly wrong. If I did this right and it builds and runs, the cube should show up in the center and then just kind of drop off screen. Thinking I might have to move the cube further away for us to see it actually on the ground, even if we put a collider in. Taking longer to build because we haven't actually built it with the physics engine before. And it didn't move. Why is that? It's there, but it's not moving. Well, at least let's see if it's actually saving an initial rotation. I have to figure out why it actually didn't simulate or why gravity didn't affect it. Yeah, that's bad. Can I, in the render, no, in the main, not the main, but the app main. It's these guys. When I set it up, where did I do that? Here. Can I actually give it a rotation? Angle. Actually, why is it only take an angle as a matrix, a 3x1 matrix? Oh, that's cool. So they're Euler angles, I guess. I want a angle vector, huh? So is that Euler angles? Look at the getting started. They talk about the angles here. Rigid body rotation, no rotation. Then why is there a 5 there? I don't get it. Why would they have a 5 when they say, oh, the default is no rotation? So if these are Euler angles, they're like angles along the X, Y, and Z axes, right? Okay, I mean, that's fine. I don't really... I prefer axis angle or quaternion, but that's fine. So we'll do into... So let's give it a slight rotation along the X would be... Yeah. I don't know. Let me just type in random numbers here, because I should at least be able to see that the cube is rotated now. It's not that we got issues. Okay, it's rotated. It's still not falling though. Why is it not falling? It should fall when we run the app's redraw, whenever it redraws. We step the simulation, right? Here's our gravity vector. Why is it not falling? Yeah, this is gravity right here. Step takes gravity. Oh, maybe because does it need mass? It probably needs mass. And I never set the mass, so let's set the mass. Back in new. Yeah, we never gave it mass. Additional mass? What does that mean, additional mass? Okay, go back to the thing. Translation, rotation, position, linear velocity, angular velocity. Starts out with 0. Gravity scale. Default's 1. It can, oh, maybe because it's asleep. Maybe it starts off asleep. Maybe that's a problem. I'm just guessing now. Can sleep. Let's say it never sleeps. Oh, it didn't like that. Why not? This was a comma. There's of course there's a frequently asked question, a common mistake. Of course Raimu is going to make the first common mistake. See what that common mistake is. Double check that the gravity vector is non-zero. The rigid body is a dynamic rigid body. You didn't lock the translations of the, how do I lock it? The rigid body has a non-zero mass. Okay, do I just have to say additional mass? Total mass of the rigid body equal to the sum of this additional mass and the mass computed from the colliders. Oh, I never gave it a collider. That's why. All right, it didn't have a collider, so it never actually had any mass. It has a unit mass now. Oh, there it went. It was quick, but did you see it? Whoop, there it goes. So I suppose that if I made it, actually no, mass doesn't matter, right? Eve, like one of the very first things you learn in physics is without any air, a heavy object falls just as fast as a light object. Right? Mass only really matters if it's 0 or non-zero, or if you have two things hit each other. Then how they conserve momentum depends on the difference in their masses. So we can leave that as a unit mass, and actually I won't need to do that when I add a collider to it. But thank you, A squared. Yeah. Gravity alone wasn't enough. I needed to actually give it some additional mass. I probably don't need to tell it can't sleep, right? Now I need a button to say reset, right? Mass only doesn't matter if you have constant gravity vector, which is there's a really big object here. Well, you need at least some mass. If there's got no mass, it's not going to be affected by gravity. Okay, let's add a collider to the cube and the ground. And where do we do that? I don't actually need the collider, so I can just add them here, right? Physics dot colliders. Insert. Let's just see how it works here. In this example. Okay, they use a collider builder. So let's do the same thing. Can I make a cuboid? Can make a cuboid. Half extent. So it's the half extents, because I'm scaling it down, will be 0.5, right? Build. Okay, but it's not enough to actually add the collider. I gotta tie it to the rigid body, right? That's what this insert with parent means. Okay, insert with parent. And it's the collider. Then it's the rigid body handle. So that would be a rigid body. Already is a handle. And then it has to get mutable access to the rigid bodies. So that's physics world bodies. Okay, now I need to add a collider for the ground. So let's do that. That's similar, only I don't actually have to associate it with a rigid body because it's not going to actually move. So that's going to be different. I just insert it, right? I don't need to have a rigid body. So can I just make a flat thing? Like a rectangle? Or flat? Triangle mesh? The plane, the plane! Hey, Dr. Padawan. But on the scale of space objects, where things are much closer in mass than human versus Earth, the effects of mass for gravity are very real, and one of the ways that humans started to figure physics out. Yeah, it's the conservation of momentum when things collide. That's where the mass really matters in this simulation. How do I add the ground? They do it with a triangle, but my ground is not a triangle. Maybe there was another example here, like tri-mesh, right? Okay, so they have a more complex one, but how do they build it? Where is it? Tri-mesh. You just literally pass the vertices and indices? Okay. Try it. Tri-mesh. So it needs to consume a vector of 3D points and another vector of 3 indices? Oh, because they're triangles. Oh. Okay. Can I just hard code this? I can collect into a vector the ground's vertices mapped, I guess. So that would be this thing. Map or iter map b to something, collect. And then we're going to want to do the same thing with the indices, right? Indices dot iter dot map the index to something else. Actually, I already know I don't want to map just one index. I want to do that window 3. Window 3. Or is it it's not window. How do you, is it partition? Partition? 3? Is that how you do it? I haven't actually used partition in a while. Dot collect dot build. Consumes an iterator creating 2 collections from it. That's not what I want, is it? Like, how do I get groups of 3? That's what it's going to want me to give it. Maybe it is 2 iterators. Chunks. Is it chunks? I don't know. let's learn something new. Is it chunks? It might be chunks. Aha, it is chunks. Thank you. The big folk. Chunks. Give me the chunkiest chunks. It's on a slice though. I guess we would chunkify it and then iterate. Does chunks give me an iterator? It already gives me an iterator. So then I map those chunks into something. So this is like I3, 3 iterators. Yep, a chunk of size 3. Hold on. It gives me slices, but those slices all have size 3, right? Okay. So what form does each vertex need to be? It just needs to be a vector, right? A vector 3 of position. Actually, I don't even need to make a new vector, do I? I can just say, well, where am I? I'm in the wrong file. Okay. I can just say v.position. Wait, what's the type of v? Vertex attributes. Vertex attributes. Yeah, v.position. I didn't like that. Oh, it's private. I guess we can add. Yeah, we could just make something we can give to map. We're gonna call it position. Import it. Yeah, we don't have a position yet. Let's add one. Really want to add it to that line. There we go. Function position self f32 3. Borrow that. Actually, then I don't need to say the size. Well, but we want to be explicit, right? Why not? It's just self.position borrowed. Okay, so back here, it probably needs me to do an into, right? So then I have to just do this v.position into. That needs to be a function call. Still doesn't like it. It's private. Well, of course it's private because by default it's private. Make it public, please. All right. The bound algebra point from not satisfied. So I need to do it manually? What exactly does try-mesh need? It needs a point. Okay, fine. We can make a point. I'm surprised you can't convert a point from a slice. So that's point. New, I guess. P dot P0, P1, P2. Multiple items. What the heck? Because it's F32. No, F32 is what we want. Hold on. There's also array chunks if the chunk size is constant, but it looks like it's slightly only. In this case, you probably want chunks exact. Array chunks is great, but unstable. It doesn't like the borrow. It was suggesting position into. Really? So I could avoid constructing the point manually by doing dereference v position and then into? Okay. It's the referencing it didn't like thing. I didn't look at the error close enough. Oh, try dereferencing here. Okay, I see. Out of curiosity, what did I do wrong here? Why didn't that work? Does point not have a new that takes 3 things? What do I need to say, 0.3? Okay, just 0.3. But this is better, right? Okay, and then I gotta do the indices. So they want they want a vector of arrays. So they want array. They want me to emit an array here. So literally that out of I3. So I3. Can I just do I3 into? I don't think so because it's not going to know the exact size. So this is where the chat was talking about chunks exact would be good because then the type is it's the type is still a slice. Chunks exact doesn't really matter. Is it this into again? I3 is a reference, so it like needs to dereference it. Nope, that's not it. I should just read it. Oh, it needs to go from U16s to U32s? Discard the extra? We shouldn't be discarding the extra. Alright, so let's just do it, man. So this is 3, 0. I am running out of time. I think we'll be able to get this done in time. Okay, I need to like dereference in front of all of them. Doesn't like that. Can't be because they are not references. But what does it not like? Can't collect into an array? Oh, it just needs me to do U32 from. It's picky. I can understand that. There we go. Jeez, that was a lot of work. Yeah, it's picky about the types there. It'd be great if I could just say I3 into, but there's too much for it to figure out, right? There's the fact that I3 is a reference to a slice of U16s. So the size might not be 3, and then there's the fact that we had to go from 16 to 32-bit. Yeah, a lot of stuff. Anyway, we built the ground. We gave it a collider. Let's see if the cube falls onto it and bounces. It should now, right? Array type might not work. Oh, it fell off. Did you see that? I need to pull the camera back. Essentially push the ground out and the cube out. Because right camera is fixed at the origin right now. So let's move the cube out to -10. And I need to make the ground bigger. Or at least move the ground out. Let's move the ground out. That's the easiest. Where do I set the ground? That's in models, right? Too many files open. Let's close others. Models. Okay. Ground. Let's push it out. I think that's why I had moved it. I needed it to move. I needed the ground to be under the cube. So if I moved the cube even further out to 10, then I think I did the math here wrong too. I think oh, what did I do? I did the math here wrong because that used to be positive 10. This probably used to be negative 10. Yeah. So if I pushed it back, so subtracted 5, then this should be 15. Actually, maybe then I didn't need to move the cube back. I think I just made the ground too light and it fell right off the edge of the ground. Up. That didn't look right. What did I do wrong there? Cuboid with, that's the right size, right? Well, the cube is scaled down by a half. So really it's these coordinates in half. So the half extent is 5 in all directions. Center is the center. So the cube is correct. But I did something weird with the ground. Oh, the ground isn't scaled. That's the problem. I don't want to scale the ground. So the problem is the scaling and the translation I'm not doing unless it has a rigid body. Oh, there it went. It fell and landed on the ground. um, let's add a button to like maybe what would be fun? Add a button that just gives it random momentum or something. It's like shoots it or up, maybe mostly up in the air. Like kick it up in the air. So we already have a button. Why don't I just tie it to that button? What would be the best way to do that? So here's what happens when the button gets clicked. If I need it to make that, if I need that to make it out of the info overlay, what would be the best way to do that? I need to find out where my info overlay is set up. I think it was set up here. No. Can't remember now. Is it in main? Here it is. How to connect these things. Yeah, I should have done this earlier. I don't have an easy way to get from the info overlay back to the app. Really just need to give the info overlay a closure of some kind, right? That calls the app. Like, yeah, let's just hack it in here. This would be like new, and we're gonna have some closure that gets called whenever we press the button, and that closure is going to need a copy of the wrapper. So yes, that means we'll make our own. Whoops. Put this outside. That, and then make another wrapper. Let wrapper equal wrapper.clone. And then in here we would borrow the app, and app dot kick. It's going to call it kick for now, and I need a new for the info overlay. Pub function new, which takes Just make it generic over some t, where t is a mutable, it can actually just be a function, right? That doesn't take anything, doesn't return anything. I think that's all I need to say. So kick the t. Oh, but the info overlay is not generic, so let's not make it generic. We'll just say that this is takes a boxed dynamic function. Self. Count of 0, average 0, FPS 0. Okay, and then let's add the kick to it. It doesn't need to be public, does it? Default. I don't need it to implement default. I don't want to call. Why does it need default to be implemented? Because I have derived default. Don't derive a default. All right, and then this just needs to be boxed. So dot boxed. Is that how we do it? I guess box new. Thought you could do boxed around something and just boxed it. Oh, I had too many brackets. Now my parentheses don't line up. Can I? I'm just curious. Can I say boxed here? I can if I don't have so many brackets. That. It keeps wanting to add an extra bracket for some reason. That. Boxed. Out. That. Okay, I guess you can't. Trying to fix my my code. Keep it like that. You're inside the closure? I didn't think I was inside the closure. Was I? So there's the closure. The closure goes to here, and then I do boxed, right? But then when I hit save and it reformats, it adds some extra brackets. So I'll just forget it. I'll just do box new. There. Okay, just make a kick for app. We can put it rare. Why not? Function kick. Mutable self. Wait, what? Oh, it needs to be on inner, not on app. Inner. Where are you, inner? Here we go. I don't know where to put it. Put it at the end. Why not? Still have an error. Doesn't live long enough because I need to move it into the closure. Now it lives long enough. Okay, let's fix some warnings while we're at it. We didn't need collider because we're using collider builder now. But yeah, I gotta wrap things up. Quick! Add the kick button quick before I run out of time. Alright, so let's kick the cubes. So we need to go to self, physics, world, bodies, get, mute. The handle is self dot models dot get model type cube unwrap. So let cube body equal. After I unwrap the cube, I got to get to its instances and fish out the first one. And then I have to ask it for its rigid body. So found, right? So it needs to be unwrapped. Okay, so we got the cube body. Let's unwrap that. Okay, so we got the rigid body. Now what are we going to do with it? Add force. Ooh, add some force. So the force is I guess it's a vector, right? And wake up is a bool. So we do want to wake it up. So we're going to have I guess we can just say that into wake up is true. Let's just initially kick it up in the y axis. I actually don't know how much force to apply. I just want to see if it actually works. Kick is never read. That's a problem. I forgot to actually call kick in the button, so the button's not going to do anything. Got to go to the info overlay and actually use it. So that was in add content, right? Right here. So self.kick. Kick cannot be called because function in kick surround the what? I need to surround the field access in parentheses. Interesting. Why is that? That's weird. Why do I need to put parentheses there? Let me try to understand that. No method named kick found a mutable reference in info overlay. It's a field, not a method. Oh, the default is looks for a method. Really, it's a okay. I kind of get that. Disambiguation between method kick and field kick. I don't actually have method kick, so shouldn't it automatically disambiguate? Maybe in Rust 2.0. Should just figure that out, right? Maybe if it was ambiguous, I would get an error, but it should be unambiguous. Okay, kick it. And it broke. What did I do? Couldn't find it, maybe? Already borrowed. Oh, does the info overlay borrow the app? So we need to pass the app back in? Maybe in add content, we have to let the reference flow through here. So probably in draw. Yeah, it's got to flow through this. Yeah, okay. Okay, the problem is we're borrowing. I can't just pass self through that, can I? Maybe I can. So the idea would be to pass self. And eProcess GUI would actually get a app. This doesn't work, then I have to move process eGUI into the app, right? That's what I have to do, because it's not going to like this. Yeah, okay, so process eGUI has to be a method of the app inner, which is not a big deal. So this just becomes a self inside the inner. No big deal. Here's the inner. which means we probably don't need to pass in those other references. That to work, it would have to delay parsing that until after type resolution, potentially. The A squared, that's just because you know the internals of how the compiler works. I'm just thinking as a user, figure it out, compiler. So that can move to here, here-ish, here-ish, there-ish. Where am I? Where did it go? Right here. Okay. So that goes there. So that don't need that. Then this goes there, which means I probably don't need that stuff. Never dereferenced. Not be dereferenced. Okay, it just figured it out. All right. Where's the error here, though? That should just be self. Pass instead of passing self. All right. One step down. So now we have to pass in the self here. So self context. So draw needs to take mutable reference to the inner. Oh, that's a problem because so maybe not the entire app. What do I actually need? Why am I doing this, by the way? What was it? It was the borrow, right? I can't borrow again. So back, yeah, that's the ultimate problem is that when I made the kick, where did I do that? When I set up the app here, right? We can't do this. It actually has to be given to us. So we need that. So no cloning the wrapper. I don't need this anymore. That the closure, this has to actually take the app, right? Well, it has to take a reference to the. That's what we want. We want to pass in that reference, right? Think about this. Yeah, it has to pierce into the inner. I don't like that. I don't like it, but we're gonna hack it in there. So it's inner. Well, app is a mutable reference to an inner, which I guess that's all we need to say. It's just that that is not a public type, so I have to make it public for the moment. Okay, we'll do it. We'll do it. Inner, make it public. Oh, I hate this. Do it. Make it public. Where is it? Simple inner. Where is inner? Oh, it's up here. Oh, I hated that. Okay, so then import it from the crate app. Ooh, yuck. And then kick. This needs to be updated. Okay, and then when we call it, we have to pass the app back out, and that means we have to get it in. Right, so following this chain, here's where we pass the app. Borrow. Oh, feels wrong. Feels wrong, and Rust is going to tell me it is wrong somehow, right? Requires unique access itself, but is already borrowed. Shoot. Closure requires unique access to self, but it is already borrowed. Closure construction happens there. Dang it. That's right. Not unique. Shoot. Okay. Roadblock. I have to go because I have a work meeting, but it's a borrow checker. The borrow checker has said, stop what you're doing. This is wrong. So I borrowed once here, but then I borrow another time here. And this actually is a mutable borrow, right? Because this run is, no, this is a mutable borrow, and this is an immutable borrow of self. So that's the borrow checker problem. I have angered the crab. So I'll have to approach this at a different angle, and I don't have time to do it. So I'm going to leave you with the cube that's sadly sitting on the ground while I raid someone, and we'll fix this tomorrow so that Kick actually doesn't panic. Kick panics right now, but we'll make it not panic tomorrow. But hey, we got a physics engine in there. It like does physics for a whole like second. I mean, isn't that cool? I guess I could have it fall slowly. All right, I got a jet, so we're going to just raid Primogen again, I think. Here we go. So I hope you enjoyed watching. We'll hopefully fix this tomorrow so that I can actually have a full loop where the UI interacts with the physics engine and we actually do stuff. Until then, thanks for watching. Yeah, I know. Sorry, 715209. You're a little bit late, but bye. But before bye, look, I got a physics engine integrated. My cube falls and lands on the ground and sits there. That's something, right? Okay. See y'all next time and around the same time. I need to actually update the schedule thing in my channel so that it actually shows my schedule since I have one now. But see you later. Bye-bye.